Hello, good evening. It looks like some are still joining. If you can tell them they join quickly so that we start this session. I want it to be just a short session. We don't want to spend a lot of time here. So if they can join quickly, we chat a bit and then I release you. We give them maybe some 5 minutes what they're about, and then we can get started. the distribution of supervisors for your projects, both groups, and just some bit of housekeeping before we get into the detail of what I want to discuss. So one, it's up to you to quickly engage with your supervisor and agree what you will do for your final year project. The current situation is that we have classes that I think only one or two members of those classes have finished their projects and will graduate in December. The rest of the classes, they just squandered their time. The rest of the members of the classes just squandered their time, and now it's not possible to finish the project because time is up for this coming graduation. Now, I wouldn't want any of you to get into that kind of situation. As you are aware, it has been mentioned that we're likely to have a graduation mid next year. Now, this work that you are doing, or these projects that you're doing, probably you have been taken through some of the requirements, is that you're preparing a proposal in the first semester. This one you will prepare, you will present, we will grade you on this one. So there will be a mark for your proposal as equivalent to a unit in the first semester. And then you will now go ahead and do the project as per that proposal in your second semester. And again, that one will be assessed. It will be marked and it will be awarded a mark as a unit in the second semester. So this project caters for 2 units. If you do a good job, you get 2 straight A's. It is easy to score very highly in this exercise, as I've seen some students do. That's the first one. The second one on housekeeping is that we expect you to do your own original work. We expect you to do your own original work. That means we don't expect you to submit copied work. So if you choose to go and pick somebody else's work and try to submit that, there's a big probability that amongst the panelists, there's somebody who has come across it before, or maybe they even supervised it. This year we've had situations where somebody was saying he went to the lab and he didn't go to the lab, and we were able to prove that he didn't go to the lab. He never stepped into the lab, and therefore we rejected their work, and now they have to start afresh and do their work again. Another one went and copied a project. Unfortunately for him, the supervisor of the projects that he copied from was in the panel. He simply said, okay, this project I had supervised some time back. He went and pulled the report of what he had supervised, actually asked the student to send the report and compared it, and it was word for word. So we urge you strongly that as you proceed now from here to do your projects, please, we expect you to do original work, not copied. In case you find a challenge, a genuine challenge, because sometimes some guys want to just create challenges for the sake of creating challenges. In case you find a genuine challenge and you're not able to make progress, please raise that challenge with me. There's a whole maybe 52 or 54 of you that are into the structures, and we have distributed you to the lecturers who are able to supervise 50th project. In case absolutely you find that you are getting stuck, don't wait until a lot of time has been wasted. Please raise whatever issues you're having. You could raise them through your class rep to me, or you could raise them directly to me. There's only 52 or 54 of you. So I don't think it will be a big headache, so that we see if it's something that can be sorted out quickly. The fourth item on housekeeping You see, university training is both, we want you to learn, but we also want you to learn how to work with people. Okay? Why am I mentioning this? I have one or two cases of students who went and quarreled the supervisors. So the supervisors have folded their hands, and these fellows cannot move. So who is losing? Is a student. My suggestion is that you try to build a good working relationship with your supervisor so that you don't unnecessarily bring tension. We don't want to be solving conflict all the time. It is wasteful, it is inefficient, and we have better things to do than to be trying to solve conflicts between students and their supervisors. The fifth item for the housekeeping. Maybe where is this? Maybe we could record this session. Whoever set it up, is it Caesar? Maybe you could record this session. Then you can, if you need to refer to it, you can refer to it later on. So I've mentioned that we expect that you will do. Caesar, are you able to record this session?
No, sir, where I am right now, I cannot record it.
Okay.
Okay, I'll record.
Okay, perfect. Thank you. John. Okay, John is recording. Elvis is recording. Thank you. So you said housekeeping. You said one, you try and do your original work. Please don't copy paste work and present it to us. Two, we're saying you try and I think, what did we say? You try and avoid to be time bad. We've said also that you try and have a good working relationship with your supervisor, because that way then the work goes a lot easier. There's something else I've said, I've forgotten. There's a last one I wanted to mention before we go into the content of what I wanted to say. Okay, if I remember, I'll say. So why I've called this this meeting is to start you off. A lot of times when you guys are starting to think of what project to do, some bit of time is wasted just going round and round trying to think what you want to do. So I want to mention briefly the categories of whatever is available in terms of possible projects that you guys could do that would be acceptable. So category number one is what we call experimental projects. Category number one is what we call experimental projects. You could write a project based on some experimental work that you're doing in the lab. Under experimental projects, you could have an array of branches. The first one is you could study a material. And this one is very common amongst our students, in TUK and many other places. You could choose to study a material. If you look at the projects that have been done in the last maybe 10 years by final year students in TUK, you find that most of them are studying materials, studying concrete with this or concrete with that. Okay, so you could choose to do an experimental project, and one of the branches of experimental projects is a material. You could choose to study concrete or its derivatives. You could choose to study other types of materials. For example, last year I had a student who proposed to use some material, some fiber mesh and things like that to make panels. So that is some form of material you could use to study some aspects of timber, for example. You could choose to study some aspects of new materials like EPS that has come into the market, etc. So that's one possible branch of experimental projects. We are still on number one, experimental projects. You could also choose to study structural elements under experimental projects. For example, You could choose to study some behavior of some beam with some unique features or some unique reinforcement or from some unique material. So one student last year says, I want to study cracking behavior of this material, of a slab. Okay, because we discussed the theory of how you calculate cracks, and hopefully we will also do that in the unit for low-rise structures. It's part of what I intend to cover. Okay, so he said, I want to study the cracking behavior of, I think it's fiber reinforced slab panel something. Okay, so this is not really a materials study, is an element study, structural element. Okay, maybe somebody could decide to choose to study beams with openings. Okay, maybe for your level, not very much, but at the master's level, I've had a few students studying beams with openings, you know, things like that. So this is still experimental, but it's on structural elements as opposed to on materials. You could study, for example, columns. Okay. Or you could study some retrofitting materials. Like we know that carbon fiber is used for retrofitting. We're asking ourselves, can we use sisal fiber for retrofitting? So we have a beam that has been loaded to failure. Can we repair it using, instead of carbon fiber, can we retrofit it using sisal fiber? Because sisal fiber is very strong. So now you're studying not just a material, but a structural element, a certain aspect of structural element. These fall under category number 1, if we may call it that, is these are experimental projects. Okay? Then, away from that category, and what I've given as examples is far from exhaustive. The possibilities around that area are almost infinite, what you can study as an experimental project. So it could be material, some type of material, or it could be some type of structural element unique. Maybe you're retrofitting or you're just studying a particular behavior or something. The second category, which you could choose a project from, is design projects. Okay, I know design projects have not been very popular with the Technical University of Kenya, but if you choose to do a design project and there is a unique aspect that you're studying something that we will be able to learn from, then that is an acceptable design project. I'll give you 1 or 2 examples. So one student decides to study or to do a design, comparative design to the BS and to the Eurocode of some building, some high-rise building. Did an extremely good job, extremely good job. This was last year. Yeah, it's the group that I supervised last year. Did a very, very good job of this work. Excellent work. And not only myself, I was happy, but the panel was generally happy at the level of detail that he was able to pull out these two designs and to be able to compare the different aspects. So this is a design project. Another example of a design project that could be unique is, I think I have had students who have basically just compared different slab types, you know. So you run designs for this slab type, so including the traditional and the newer in quotes, slab systems that are being proposed, including things like EPS, etc. So some student has decided to do this, and of course he has the whole array of slabs designed. He has the whole array of these slabs, different spans designed, and then he pulls out the costings, and then he compares the costings, and from there he's able to draw a conclusion to say, so generally, if you have this kind of spans, this kind of slab is most efficient compared to the other types of slabs. And it is a design project, but the output is not just to say provide 4 T25s. The output is beyond that. And this is the kind of, if you choose to do a design project, this is the kind of outputs we will be expecting you to give at the end. So, in my opinion, absolutely, you're not prohibited from doing design projects. Please, somebody who feels that they want to do a design project, go ahead and make a proposal between you and your supervisor, but show us what is unique, what is the extra thought that is going into this work from your project. Then, if it is reasonable, most probably we will approve and you'll go ahead and do this. That's the second category. So we've talked, I'll remind you, we've talked about laboratory based. It could be materials, it could be structures, structural elements, etc., etc. You could do a design project. So I've given you 1 or 2 examples of that. You could also do a descriptive project. You could choose a structural engineering problem, something that is a headache, and describe it. Do a study on it, describe it, and write a report on it. I'll give you an example. I'll give you 2 examples. So some time back, I had a student who said, Mwalimu, I want to study the steel recycling industry in Kenya. So I said, yeah, please, let's formulate a project from there. So he went, did some questionnaires, interviewed the whole chain of the recycling, from the chokora who comes to steal your manhole cover, to the middleman who collects these stolen items or whatever collected items from the chokora, to the factory, to the owner of the factory, who now melts this and creates reinforcement bars and some other steel products. They got a lot of very interesting data. Then he put together this data, wrote a report on it, and in addition went ahead to say, so how are they doing recycling in a well-established economy that has a recycling component? So I think he then studied the case, was it China or South Africa? I think he studied one of those, and he then did a case study to say, this is how it is done in that country, and these are the reasons why it is succeeding, and these are the reasons why we are not succeeding here with this one, and this is the way forward. Or then he suggests this, and he wrote a very, very good report just on the problem of recycling. Now we know we are recycling. We know that we are collecting bits and pieces. You find those kids with magnets. They are going to pick the small scraps of metal and everything, and this industry is of great interest to us structural engineers, because you will remember, was it last year or the year before, an electricity pylon fell because of vandalism. They come for this material. Okay. Recently, a former classmate who is an engineer in one of these water organizations, because he says, engineer, I'm having a problem. I need to create manhole covers, but they cannot survive because these guys come and break them and steal the reinforcement. So I tell him, the problem is not that you are reinforcing the manhole cover. The problem is you are reinforcing them with a material that is too lucrative. Change the reinforcement and see whether they will come and steal. Put some fiber mesh of some sort, plastic fiber mesh or something, and because we know the strength of whatever plastic you're using, and we can do a quick design calculation, and then we can test this in the lab. Of course, it's never come back to me yet. I think things in government move slowly, but you guys, somebody could pick that up and do that as a study. If you can find the fiber mesh, whatever fiber mesh that you can lay your hands on, plastic, And that kind of study would be very useful. We remove it, we get it out, we put together something like a paper, we take it to the IK conference maybe in the coming year, and engineers are interested, because then we are saying we can make these manhole covers, we can reinforce them with material that the recycling industry, steel recycling industry, is not interested in. So they will not come and steal them, they will not come and break them. You see, so you can describe a problem. That's the third one. Sorry, I've digressed a bit. You can describe a problem. You can describe a problem and write a good project from it. I'll give you another example. Some few years ago, maybe 2-3 years ago, there's a gentleman who wanted me to supervise his PhD, but then he's gone underground. I know what happened. When you have, even where I'm sitting in this office, the wall behind this cabinet borders the wall of the neighbor. So they are basically almost touching. I think it's like an inch between the two. So whenever it rains, that space between the walls becomes very wet. And the water then percolates to the east side of to this side and also that side. So this space was repainted recently, but unfortunately you can't see. But next to where the door is, that wall there, it's damp and the paint is doing like blistering. Okay. Now that is a problem that an engineer should study and tell us. Of course, there are products that currently are available that you can scrap the paint, and before you put a new coat of paint, you can put this waterproofing. I know one gentleman who now teaches at the University of Nairobi. For his undergraduate research, he actually studied this problem and wrote a very nice report. A very nice report. I'm thinking the walls he studied, they might still be in the concrete lab at the University of Nairobi. Last time I was there, they were still there. It's maybe 10 years plus now since he did that work. Okay, so this could be a descriptive problem. Another student of mine said, I want to study flat roofs and why they are leaking. So she went, looked at the buildings that have flat roofs that are leaking, described the problem, what, and eventually suggested what solutions could be applied. Not a very nice final year project. This is just descriptive. Another student asked, how is the uptake of BIM in design of buildings in Kenya? BIM. Took this data from the professionals, the engineers, the architects, the QSs, wrote a very nice report. We even pulled a publication from it. So that's the other direction you could go. The fourth broad category is analytical. Now, I don't expect you guys to want to go that direction because analytical is a bit more involving. 1. 2, you need to question the theories that are available already. So I'll not talk very much about this, but I want to talk about something else that you guys are good at. This is computers. Okay? Computer modeling of software creation, modeling of certain features. And I'll give you an example of what one of my students did. So this student is very good at programming. He says, Mwalimu, I need to do something to do with programming. I tell him, okay, so we will do machine learning for a problem that I've been thinking about for a long time. Now, if you guys, what artificial intelligence is, machine learning. So we can have a set of data and we can train the computer or a machine to know or to be able to predict some parameters of that data. I'll give you an example. So behind me is a door here. There's a door here. So we can put a camera that is able to pick the height, to measure the height of the individuals that go through the door. And then we collect that data. So 1,000 people pass through there. And from that data, we can train the machine. That's why it's called machine learning, or artificial intelligence. We can train the machine to be able to say the next fellow that will walk through that door will be 5'5". Maybe the next male that will walk through that door will be 5'5". The next lady that will walk through that door will be, say, 5'1". Okay, so that's machine learning. So what this student of mine did, maybe now 3, 4, 5 years ago, you see, it's possible to predict the porosity of a concrete surface just from the image, just from the photo of that surface. So that's what he did. So he took a lot of photos of concrete surfaces, of cubes whose porosity he had tested. He used that data to train or to create a machine learning model, and a neural networks model. And then now he was able to create a model that you can take a photo and you feed this photo to this model, and this model is able to tell you to predict or to approximate the porosity of that concrete without you taking a sample of the concrete to the lab to test for porosity. So it's almost like instantaneous. I wrote a very good report. We were able to pull out a publication from that, peer-reviewed publication from that. So you guys, because you're good with computers, you could look at the engineering problems that we have. Maybe someone who is good with computers, you could go that direction. That would also be a really exciting final year project for you guys. This is not an exhaustive array, but I just thought to bounce these thoughts to you at this point when you are about to start your projects, okay? And we are willing to support you as much as possible with these projects so that you're able to move quickly. Up to that point, I want to pause and allow, if somebody has a question or a thought you can share before I say maybe one more thing, and then we close this meeting. We had said we will do 40 minutes or thereabouts, so we're just about there. Any question, any comment, any thought that somebody might want to share with us before I say the last one? Okay, so silence means...
Will you?
Yes, Ayub, you want to say something? Please go ahead, Ayub.
Are you the one who will choose for us just a topic, or will come up with our own title?
No, you choose your own topics. That's why I'm giving this general talk to open up your minds to say what you want to do. You choose your topic, you go and discuss with your supervisor, you agree. If they're happy with that, you write a proposal on it, and then you come and present to us.
Thank you.
So you're free to choose. Okay, great. You're free to choose from this array or any other that is structural engineering. This array is not exhaustive. Yes, any other thought that somebody has?
Yeah, I have one.
Yes, this is Mutero.
Yes. Are we restricted to only the structural engineering bit? Because, okay, for example, we had a water option, but not many people took it, so they are not going to be proceeding. But there are challenges and problems within the water engineering field that, for example, I'm interested in pursuing, or am I restricted to doing structures because that is what I'm specializing in?
Okay, so that's a good question, Mutero. So the list that I have allocated supervisors is for structures units, but I'm aware that some of you guys opted to do the water option. Maybe there are some who opted to do transportation engineering who are in this meeting. So in the same line of thought, now you need to pick your idea and discuss it with a potential supervisor in that area of specialization. Because, for example, if you came to me with a water proposal, absolutely, I'm not able to add any value. I am really, really lost when it comes to water. But we have the experts in that, so you would now need to discuss with those experts in the water. We have many of them in the school. So that then you develop a proposal.
Okay, thanks.
Okay. All right, great. Any other thought? Okay, great. So now I want to talk about timelines. I have a concern since we are to complete our proposal this semester and we are in our mid-semester. We require to come. Okay, so Tevin, there are two ways of looking at life. This is now not just specifically to your question, but to all manner of challenges that you find, which you will most definitely. If you always seek to find the reason why you cannot do something, then you will not do anything. If you always seek to find the justification why something cannot be done, you will not do anything. But if you say this needs to be done, how can it be done? Then you find that you're always successful, not just in one item, but then that becomes your it's almost like your character. You've heard of people say there are people who anything they touch, it becomes gold. It's not like they have magic hands. It's all a mentality thing. So I'm aware that we are in the middle of semester. I will tell you for certain, if you wanted, you can put together a proposal. You can put together a proposal in 1 week, not 2 weeks. 1 week you can do it. This final year project proposal, you can put it together in 1 week if you wanted. So I'm not worried about that we have, I don't know, 7 weeks to the end of the semester. It's neither here nor there. This, you can put together a proposal in 1 week. I've had students in TUK who have done it. 1 week, we discussed the first time. The second time they come up, we meet again in a week's time. They have some form of write-up. They have some slides they have prepared. And we're just cleaning it up and saying, okay, so in the next 2-3 days, we can put you into the presentation. And they present. It's really a small thing. But if you want to make an elephant of it, of course, we've had guys who have been working on this thing for a whole year. They're still not yet presented their proposals. It's all in the attitude that you have. But I'm telling you for certain, if you want, even within 1 week, you can put together a proposal. It's not a difficult thing. You've done things that are a lot more involving, a lot more demanding than writing a final year proposal. And then you're setting your own syllabus. It's not like a syllabus is being set for you. I'm telling you, choose anything you're interested in. Mutero has just told us he's interested in a water problem. He has every right to study that. I just told him, please look at our pool of lecturers, whoever you think is able to guide you, and pick this up with you. And you can start even tonight. If you start tonight, within a week, by end of next week, you probably have a proposal. It's that easy to write proposals at your level. So I don't think we want to make a big fuss of it. So somebody else was asking a question here. So Tevin, please, this is my thought about your question. Cleophas Omondi is saying, can we choose bridge, dam, or retaining walls? Okay, so dam is in water. Okay, so if you choose to do a dam, you need to pick a supervisor from water, unless you want to choose an aspect of the dam like the tunnel, because the tunnel is structural engineering. Can we choose a bridge? Of course, you can choose to work with a bridge, bearing in mind the thoughts that I have shared. Or if you want to choose to look at retaining walls, bearing in mind the thoughts that I've shared. That if it is design, what is it that you want us to learn from that work? It should not be just design that we wind up to say, so provide 8Y16 or 8T or 4T20. Then we are not learning anything. Okay, and I've given examples earlier. This session, I said, let it be recorded. Please get the recording if you were late, and look up what we said at the beginning. Okay, any other issue? I want to talk about timelines. Please ladies and gentlemen, I'm imagining that I believe that there might be some ladies in this meeting. Ladies and gentlemen, let us try and get the proposals by the end of the semester, if possible, before the end of November, before we go into the exams. We are willing to start giving opportunity for presentations even next week, this coming week. I will allow you for the thought process, maybe 1 or 2 weeks. Then from there, please, if you have something, that can be presented, please agree with your supervisor. Let's schedule you for a presentation, and you make a presentation of that proposal. And do not fear when we tell you, please, this one you have to correct, or this one you have to correct. That's part of the process of getting it right. It's part of the learning. It's like now you're in class, but to do this particular project. Somebody else has asked a question here. If, for example, have settled on a particular topic in structural engineering, what am I supposed to cover in the proposal? Okay, so you pick this now with your supervisor. Okay, I didn't want to go into the details of that because I'm imagining that whoever is in charge of projects generally would have taken you through that. I think it's engineer or something. But generally, you want to write. The proposal is a standard scientific document, a technical document. So you'll have an introduction chapter. You'll have a literature review chapter. You'll have a methodology chapter. Then you'll have a schedule. You'll have a time schedule of how you want to do this work. You know, what activities, what time, and then you'll have a budget. And then at the end, you'll have references. I'll repeat what I've just said. You'll have a chapter 1, which is an introduction chapter. In that chapter 1, you'll have components like you'll introduce the subject. You'll talk about your problem statement. What problem are you dealing with? You'll talk about your objectives, your research questions, your scope, your limitations, things like that. All this is in the introduction chapter. Then you come to chapter 2, which is a chapter on literature review. So you review literature that is relevant to the work that you want to do, the topic that you want to do. And then you'll have a chapter 3 that will be methodology chapter. You will write the methodology of how you want to do this work. After that, you write, you put a small section for the work schedule, how you want to do your work, and then you'll put a last section to say to put in a budget, and of course then you have to tell us your references, what you've read to come up with this document.
Pardon the chapter.
Sorry?
Chapters. Yeah,
but I've said this is chapter 1. This chapter, and this video is recorded. This meeting is recorded. So please get a copy of this and go over it again. I've said this chapter 1, in which you introduce the subject. You'll mention what problem you're trying to solve, because you don't do a study unless it's driven by a problem. So you'll have a problem statement. In that chapter 1, you'll have your objectives. In that chapter 1, you'll have your research questions. You'll have your scope. You'll have your limitations. etc. That's all in chapter 1. Then you'll have a second chapter where you will review literature that is relevant to what you're trying to study. That will be chapter 2. In chapter 3, you'll have it's a chapter that is called methodology. You'll review, you write the methods which you want to use to work towards doing this project. After that, this is for the proposal. You will have a section which is not a chapter to say work schedule or research or project schedule. So your schedule of this. So this month I'll be doing this month I'll be doing, and I intend to finish maybe in December of 2023. So you'll put a schedule, and then you'll put a budget to say I need to buy cement 1 bag. So you put the price there, like that. You say what the total is, and then you have a list of references at the end to say these are the references I've read to in the preparation of this. So that's the general layout of this document. What is required. Okay, but your supervisors, they are experts with writing this. So please, that's why I'm saying try and engage with them, and don't don't inaitwaje ile, msiwafanya wakakuwa na hasira na nyinyi. You try and be measured with them so that you can benefit as much as possible from their expertise and so that your work can go smoothly. Somebody is asking, are there any restrictions in terms of creating software that might help or prove a concept in, say, structural calculations and any other area that I might choose? I know the timeline might be an issue because of the steep learning curve when it comes to computer science. Okay, so absolutely, I wouldn't want to suggest that there's any limitations. Why I've even brought up that possibility of going the computer's way, either doing a modeling or something, is because the people who create solutions, computer solutions now, are people of your age. They're not people of my age. Really, even if you hear a certain professor has come up with this solution, it's usually the students who have created this, have thought about it, have put together the solution, and then fronted it. Okay, so absolutely, I think at this point it's prudent to listen to you. I'll give you two examples of fifth-year projects that were very, very good, that were basically leaning on the software side. So one gentleman who was behind me by 1 year, graduated, now it's 20 years ago. Brilliant guy, actually wrote a software to analyze bins. Okay, so it's not new, but I thought it was a lot of fun for him. And his supervisors actually allowed him to do that. I still remember because I remember that particular gentleman because his elder brother was my classmate. We went to the university together. So that's one. Two is a gentleman who is now my PhD student, and he teaches at Moi University. When he was writing his final year project, he wrote a software to analyze 3D trusses. And he was so good at it that the graphics of that software that he wrote, you would think you're working with something like Procon or something like StadPro. It's his own software, and he has continued working with that. Even part of his PhD is along those lines of finite element, and he's very good with that. Anybody who wants to go that direction or has a good footing in that direction, I could link you up with this gentleman. He's genius level, I think. Okay, so the rest of us are very intelligent, but him is genius level. So absolutely, I wouldn't have a problem if somebody found an interesting problem. See, the keyword is problem. If you found an interesting problem that is not being solved currently by what we have, the software that we have, and then you wrote, even if it was a small code, it doesn't have to be a fancy code. If then you are able to program a small code to solve just a small problem, that will make a very good 50-year project. Very, very good. And we will all be, personally, I would be very excited if somebody could do that in this group. Okay, so this is open. So I urge you very strongly, please quickly engage with your supervisor, and don't go to them with an empty hand. You have to have an idea. So when you call them or you get audience, they say, Mwalimu, I want to see you. Say, okay, come to my office. So when you go there, say, so I've been allocated you to supervise my final year project. I am thinking of doing this and this and this. What is your thought? So that you have a starting point to discuss. And that's why I thought to have this session with you, so that you can have a starting point. When you go to them, you're not blank. You're not going to tell them, now what do I do? I mean, that is not good. You'll not make progress. But if you go with a good idea, then the supervisor is able to add value to it quickly, and then you're able to move quickly. So I don't think at this point there will be restrictions on what you could do with computers. It should be open, and it doesn't have to be complex, but it's got to be a genuine problem that maybe we're not able to solve with the current software that we have. timelines. Please, let's try by end of next month, November, to have these proposals. We'll go out of our way to create time for you to present, so that you can cross this, so that when we come next year for the other semester, if somebody is going to the lab, he's going to the lab. If somebody is going to pick data in the field, he's going to pick data in the field, so that we all finish on time and we are able to process your results, and this does not become the stumbling block to your finishing your training. So if if there is no other question or comment or thought, please, I want to break this meeting. Thank you very much, and let's keep talking. Engage immediately with your supervisors. What I've said is, if you have a serious challenge that you think you might want to bounce it off myself, please, anytime, bounce it off me, so that we can move this work quickly, so that you get this one done and it doesn't become a stumbling block, the way it has for some people who are now finishing this academic year. Thank you and good evening.